Hello everyone, in today's lecture we will discuss a problem that is related to finding geodesic equations in R3 with spherical coordinates, and the metric tensor is given by this one, like GAB, that is equal to this. Students, over here we have x1 is equal to r, x2 is equal to theta, x3 is equal to phi, that are actually the spherical coordinates. Okay, now students, we know that if we find the Christoffel symbols for the given metric tensor, then these are equal to this one. Like all these values, these are actually the non-zero Christoffel symbols, and all the other values of the Christoffel symbols will be 0 and they will vanish. Now students, we know that the geodesic equations are given by this one, like x double dot c plus cab x dot a x dot b is equal to 0, or we can also write it as like this one, x double dot c plus gamma of cab x dot a x dot b, that is equal to 0. Now students, here C represents a free index and AB represents dummy index, and the variation of C will be equal to the dimension of a manifold. Here we have R3, so the variation of C will be for 1, 2 and 3. First of all, we will take its value 1, we will get one equation, then for the value of C is equal to 2, we will get second equation, and then third equation. Okay, and the variation of AB will be for 1, 2 and 3, and we will write it in a sum over form. For example, if I substitute the value C is equal to 1, then I will get this equation, and after substituting the dummy indices, we will get this one. Okay, and students, we know that from here the non-zero Christoffel symbols are only these ones, and all the other Christoffel symbols will vanish and they will be equal to 0. And we also know that here x1 is equal to r, x2 is equal to theta, and x3 is equal to phi. So here x1 is equal to r, so I will write it as r double dot, because here we have second derivative of x, so I will write over here r double dot, and the value of 1, 2, 2, the value of 1, 2, 2, that is equal to minus r. So I will substitute its value, and also if we substitute this, the value of this Christoffel symbol, that is equal to this one, like 1, 3, 3 minus r sine square theta, then we will get this equation, and say this is equation number 1. Then similarly for C is equal to 2, we will get this equation, and after substituting the value of the dummy index and by substituting the non-zero Christoffel symbols, we get this one or this one, because here x2 represents theta, so theta double dot, and the value of non-zero Christoffel symbols are given by these ones, so I will get equation number 2. Similarly for C is equal to 3, and after using the non-zero Christoffel symbols, we will get the third equation, because here we have x3 double dot, and we know that x3 is equal to phi, so I will get over here phi double dot, and that is equal to this one, and this is equation number 3. Okay, so equation number 1, 2 and 3 represents the non-zero like the equations where we have substituted the non-zero Christoffel symbols, and these are actually the 3 equations for the geodesic equation in R3 with spherical coordinates. Okay, so students, this is all about this lecture, where I have showed you that how we can find the geodesic equations in R3 for the spherical coordinate. This is all about this lecture. Thank you so much.